Hey everyone, this week we will be doing a special draft related thing where we will be scraping MLB draft data from every past year as well as obtaining draft data for the current MLB prospects. So let's get right into it. The first thing you'll do is you'll load in your packages Baseball R in Tidyverse, just by calling library baseball R library tidyverse. I'll actually, so if you want to install it, let's say you don't have it, DevTools install underscore GitHub in parentheses Bill Petty / baseball R, and make sure you remove this hashtag, if you will, or #, whatever you want to call it, and you can install it that way. This is just to make sure the code does not run. So you can do that, and then for Tidyverse, you just simply do install.packages Tidyverse, which is great. It's exactly what you need. Anyways, so we'll get right into it. The first thing that we're going to do is call a list, and I've actually found out a quicker way to pull these years. So we're going to say draft underscore list, and the first thing we're going to do is we're going to say 2000 to 2019. So we're going to pull draft data from 2009 to 2019, piping operator to insinuate that, hey, there's more code coming. And now we'll get into the fun part, and the part that I just learned about not too long ago. So within Tidyverse, there's a package called per with 3 R's, and there's a function called map. And what you do with map is you'll say function x, which is just a simple function, and then just to make sure that we have the correct code, we'll say baseball R ;:. So we're calling from the baseball R package get draft MLB. And then in that parenthesis, we'll say X. What essentially that is, make sure that's lowercase. What essentially that's doing is, well, it'll take each year from 2009 to 2019. You can go back all the way to 1965, but I will say that older years are a little bit more wonky in terms of columns. So I just did from 2009 to 2019 because Mike Trout was drafted in 2009. So that's where we're starting. So now what we'll do is we'll run this function and make sure there's no comma in between function X and baseball R get draft MLB. But essentially what you do is you'll say draft list, run this. It'll take a significantly less amount of time than running a for loop. And what it's doing is just getting that draft data from 2019 or 2009 to 2019. So now that we have it, we'll say draft data. And we will say draft data plier from the plier package :LD ply draft list, and then data frame, which is great. We need it. So we have this now, and we can go through it. So we have something like player ID, pick round, pick number, a bunch of a lot and interesting data. So obviously Strasburg was the first pick in 2009. Tells him his birth state, city, state, country, full name, draft year, last played date, MLB date, MLB debut. So you have all of these columns: bat side, pitcher, pronunciations. What else? Let's see if there's any else that's interesting. What team he was drafted by, other stuff like that. And we see that we may have rank, pick value, signing bonus, etc., but we didn't have NAs there, which is fine. That's not a big deal. But this is cool. So we can be able to see all draft data from 2009 to the present. And we'll go to that miraculous pick, the 25th pick from Millville Senior High School, Mike Trout. It's right there. But we can see all of these players, and we can see whether or not they made it to the MLB, and if they stopped playing the MLB, so the MLB debut date column. So this is actually really fun stuff. Feel free to play along with it. But this is actually pretty cool. You can pull a lot of draft data pretty quickly, especially with the map function rather than running a for loop. But now what we'll go into is we will essentially grab MLB, or I have a CSV file for you, a CSV file of the top 200 prospects in MLB, and then the Fangraphs board, and we're going to combine that data together to have like a big data frame of basically players, their information, as well as scouting grades from a Fangraphs perspective. Next, we have 3 CSV files that I will include on my GitHub page, and that will be in the link in the description below under the video. So make sure you do click on that to get these CSV files. We have 3 different CSV files. So we have the Draft 2020, which is the draft data CSV, Fangraphs batters, which is just Fangraphs from the board Fangraphs, their hitters, and then Fangraphs pitchers, which is Fangraphs pitchers. And so what we'll do is we'll load all of these in, and I'll let you explore some of these columns. So first we go to Draft 2020, and we can see it's sorted by rank, and we have Spencer Torkelson, who's the top prospect according to MLB.com. Position, school, class, where were they born, city, state, country, bats, throws, and then a description in here as well. So this is actually pretty cool, pretty fun stuff. And then we can go into Fangraphs batters, same along those lines. So it's got rank, name, position, age, hit, game power, raw power, speed, fielding arm, athleticism, frame, performance, and future value. So essentially what we're going to do is going to merge those data sets together into one big data set. Next, what we'll do is we will do a left join from the dplyr package, which is within tidyverse. So simply put, how you do this is we will say draft 2020, once again, we will call that data frame, and we'll say left join from the dplyr package, and our X table is draft 2020, our Y table is the Fangraphs batters, and we'll say by equals name. So what essentially that does is we're taking all the data from the 2020 draft prospects according to MLB.com, and we are merging the Fangraphs batters, or in this case left joining, all of them that match by name. So that way we have that data available. So we'll go into it before I go into the next one. So for pitchers, you may not see it, but something like this, we can see Fangraphs rank, position, age, hit, game, raw, speed, field, arm, athleticism, frame, performance, and future value. So what we'll do next, and just to make sure that I do it right and you guys do it right, so I'll say draft 2020 underscore final, and again we'll do another left join, which will say X again is draft 2020, Y is this time Fangraphs pitchers, but again we will use by name, so that way we have our data set. So now we have all of these columns, and what we'll do next is you might see like age X, athleticism X, frame X, which is fine. We can change this and adjust for this, but that's what we'll do next. So now you can see that there's a bunch of code written. I didn't want to write it out and take a chunk of the video out just for me writing code, but I will break this down for you. So what we're doing is we're calling again draft 2020 final, and then we're calling it again to indicate, hey, we're going to start adding new columns, adjusting columns, so on and so forth. So we're going to say draft 2020 final piping operator mutate at. So essentially what mutate at does is you want to change a bunch of variables into, say, a different variable type. So mutate at vars, which is just short for variables, and then we'll go through each of these variables. So Fangraphs rank Y, performance X, performance Y, athleticism X, so on and so forth, and we'll change them to character variables. That way when we do our coalesce function, we can properly replace those NA. So essentially what this will do then is when I say mutate, I list all of these columns. So the X columns, the athleticism.x, frame X, performance X, Fangraphs ranks X, so on and so forth. What we're doing is we are coalescing, and what essentially that means is we are pulling from, say, this Y side. If there's an NA on the X side, it replaces it with that Y. So let's go into here and I'll show you an example. So like we'll look at Asa Lacy. So you can see right now there's no position here, but if we go to his position over here, it will be replaced with left-handed pitcher. And then same for age, so on and so forth with those. So that's essentially what the coalesce function does. And then piping out for continue code, and we're going to select certain function or select certain variables. So just name future value X. That means it selects every variable that begins at name and ends at future value X, and then, or comma again, Tommy John date to tops, which is their max velocity recorded by Fangraphs. So we have that as well. And then I essentially just renamed some of these. So instead of saying X.X, we'll say just Fangraphs rank, age, athleticism, frame, performance, future value, and MLB rank. So you can distinguish between the ranks. So we will run all of this, and now we should have all this data. So we'll go to Asa Lacy, and we can see his position and age are listed as here. These are listed as NA because, well, they're not hitters, but on the pitching side, you can see this. But now you have all of this data. Now you can create kind of some visuals or plots, and I'll show you just a real basic one here shortly. So let me give a little bit of an explainer to what kind of these mean and what these numbers mean. So scouting is on a 20 to 80 grade scale, 20 being poor, 80 being the best. 50 is about average, and these two numbers are basically current value and future value. So so like someone like Spencer Torkelson has a current value of a 35 grade of hit value, so he's well below average, but he has a potential of an above average hitter. His game power is below average, but well above average. A plus raw hitter, so 70 out of 80 is great, and he already has 65, so he's really good in that end. And you can kind of go through there. So that's essentially how the scouting scales works. In terms of athleticism, frame, and performance, if there's an NA, that just means they're average. If there's a 1 in there, that means they're above average, so a plus. And then if there's a 2, that means they're plus plus, so really good on that end. And then same goes for -1 and -2. They're either below average or really below average. So now what we'll do is we will create a plot, and I'll just break down this code for you. So ggplot is the function that we'll use to plot our data. And we'll say draft 2025, which is the data frame that we created, and then aesthetic AES X equals reorder class, comma, function X minus length of X. Essentially what that's doing is reordering the bar chart that you'll see shortly from most frequent players by class to least frequent players by class. And then we'll say geom bar, which is a bar chart, fill equals blue, so we're just coloring it blue. The X label is class, the Y label is number of players, and then we'll say labs, which is labels, title equals top 289 prospects by class type, comma, subtitle equals 2020 draft, plus geom text, stat equals count, AES, label equals count, and then the vjust, which is just moving that text of the number of players to up -1, so up 1. And we'll run this and you can see what it looks like. So you essentially can see that most of the players, most of the prospects are 4-year juniors. I know you can't read that right now, but it's 141, and then 96 high school seniors, 19 4-year sophomores, 19 4-year seniors, 9 second-year junior college players, and 5 first-year junior college players. So awesome stuff. So now what we'll do is we'll do the draft data. So ggplot draft data, and then make sure I have the correct one. So we'll say school, school, class, because we're taking that draft data of the school class as well as, so we have this, and now we have geobar fill blue, and now we'll say drafted players by class, and we'll change this to 2009 to 2019 drafts. So that way we can see that kind of data. So here we go. You can see it looks weird. There's a lot of NAs, so we can actually figure out a way to remove NAs, but we can ignore this for now. So we have some juniors, 871, 639 seniors, 499 high school players. So I assume combining these together would put it behind or just ahead of seniors. Looks like we can combine these two, but junior college, so J2 just means second year junior college. First year junior college, looks like there's a 5S, which is I think a kind of graduate senior. J3 with I think it's like a redshirt sophomore in junior college, but you can kind of see this kind of stuff. So thanks for watching. Really hope you enjoy this video, and I hope you watch the MLB draft. I will be posting some analytics on those players who were drafted, either Division I, Division II, or Division III, so you can see that for yourselves. So be sure to follow me on Twitter at Robert540, and once again, like and subscribe if you like this for future content. And again, thanks for watching. Hope you have a great day.